Today, we're going to make a texture that tiles infinitely but never repeats. Let's go. Okay, so today's pretty big. We've been building up to this tutorial for the past 5 weeks, and today I'm going to show you what all of the effort has been for. We're going to tile a texture without ever repeating it, so there are no tiling artifacts, no seams, and no repetition. Normally, if I just tile a texture over and over, the result is pretty awful because of the repetition. But with the technique that I'm going to show you today, the repetition is gone, and I can tile my texture infinitely. If you haven't been following along, it's really important to work through these videos in order, so that you have all of the pieces that you need for today's video. So I've created a playlist with all the videos you need, and check that out down in the description. So first, let's start out by taking a look at the final shader that we're going to build. We're going to start out in Unity, but we'll switch over to Unreal, and I'll show you how to do the same thing there in just a minute. So first of all, here on the left, we have our UV coordinates coming in, and they're plugged into this UV transform node. And we created this node in episodes 42 through 44. So this node takes the set of UVs and it applies random scale, rotation, and translation. And so I get a different set of random transforms for every unique value that I pass into this random seed input port. And I can control how much rotation and scale to apply using these input parameters. This node down here at the bottom is where the magic happens. This is the node that we made in last week's video, and it generates a set of hexagonal grid tiles. Let's take a look at the output from the Hex Grid tiles node. I'm just going to take grid ID number 1 and plug that into color so we can see what it looks like. And what you can see here is that I've got this grid of hexagonal tiles. Now, the values go above 1 and below 0, so we can't see each individual tile. Let's just go ahead and multiply this by a small number so that we can visualize it a little bit better. So I'm just going to multiply it by 0.1, and then we'll plug that into our base color and our emission. And so what you're going to see is that each tile has its own unique ID. And so these unique ID values are what I pass into the random seed. So for each individual hexagonal tile here, I'm getting a different set of random rotation scales and offsets. And so I'm creating 3 of these grids, and then generating the random offsets for each individual hexagonal tile. And then I'm using the resulting UVs that I'm sampling here, or that I'm creating here, to sample my texture 3 times. Then once my texture is sampled, the last piece of the puzzle is to blend the 3 samples together. And I'm blending the samples together using this weights value here. And this is the main thing that we worked on in last week's video. So let's take a look at the results coming out of this weights value. I'm just going to wire this into my base color and emissive so we can take a look at what it looks like. And there we go. So the output of weights is generating a red, green, and blue grid. And this is what I use to blend between my 3 texture samples. So sample number 1 is red, are the red tiles, sample number 2 are the green tiles, and sample number 3 are the blue tiles. And I can control how much blending there is between the individual tiles by using this value here called grid focus. So if I set this to 1, you can see that now my tiles are really blurry. If I set it to 3, they're a little bit sharper, and the higher this value goes, the tighter the focus is on my grid tiles. So I can use that then to blend between my samples. Let's take a look at the final result and see what this focus value actually is doing there. So if we zoom in on my grid, if I reduce this value down to 1, now you can see there's a lot of blending between my individual texture samples. And as I increase it, the samples get sharper and sharper, and the blend zones between them get smaller and smaller. So if I go up to like 32, for example, now you can see that there's a very small amount of blending, maybe even up to 64. Once I get this value really high, you can see that, whoa, now we get some crazy stuff if I go too high. But you can start making out the individual hex tiles here by the sharpness of their edges. So I like to keep this value at around 12, so there's blending between the tiles, but the tiles aren't quite as obvious. Okay, so we're going to build this shader today to allow you to tile textures infinitely. And the first thing that we need to do is focus on this Hex Grid tiles node. So we worked on this last week, and we're going to pick up where we left off. I hadn't showed you how to expose the parameters yet, and we also hadn't exposed these grid ID values. We worked on the weights, and we created that red, green, and blue hexagon grid, but I hadn't shown you how to expose these grid ID values or these parameters. So let's go back and pick up right where we left off last week. Okay, here we are back in our Hex Grid demo subgraph that we worked on last week. And to help keep this organized, what I did is I split out, because this is kind of a complicated shader to create, what I did is I split out our shader into 4 different parts. Part 1 creates our checkerboard grid. Part 2 turns our grid into this hexagonal mask. Part 3 sharpens up the mask, and we created this value called hex focus here and exposed it to our blackboard. And then part 4 conditions our UV coordinates so that they create a hexagonal grid instead of a square grid. And so what we're going to be doing today is building part 5, which outputs 3 distinct hexagon grids, or our grid ID values. And so we're going to build part 5 right over here. Like I said, if you haven't built this yet, go back and watch last week's video, because I go through in depth, step by step, for how to build all of this. And we're just going to pick up right where we left off. And I'm going to start right here with the output of part 1, this round value that we've created. And so I'm just going to drag out here, and we're going to create a multiply node. We're going to multiply the result of our round by a value here that is going to determine whether or not we need to flip this value. So here, I'm going to create a branch node. And if the result of my branch is true, I'm going to give it a value of 1. And if it's false, I'm going to give it a value of 0. So I'm going to wire this into my multiply so that I can flip this value on or off. Now I'm going to come down here to this comparison that we created previously. So basically I'm comparing the value of this, if it's 0 or not. And so I'm going to take the result of this comparison node that we created last week and wire that into my branch. So I'm just going to drag up here, wire that into the predicate node of my branch, and it's going to be 1 if it's true and 0 if it's false. Okay, now we're going to take the results of this output, and I'm going to split it into the separate red, green, and blue channels, because we're going to use each of these channels independently. Okay, now let's come back here to our round node. And I'm going to create a bunch of swizzle nodes. We're going to use 2 individual channels for each of these. The first one's just going to be XY. And I'll make a new one. And this second one is going to be ZX. And then the third one is going to be YZ. And so this is where I'm getting the individual UV coordinates for the 3 different hex grids that we're generating. All right, before we go further with these swizzle values, I want to come back up here to this red, green, and blue mask that I've created, and we're going to add some values to this. So first I'm going to drag out a line here, and we'll create an add node. And we're going to add this value to the floor node that I created way back here at the beginning of part 1. So I'm going to grab this value coming out of floor and wire it into add. So we're going to add those values together. I'm going to do the same thing with the green and the blue. So I'll add our floor value to that. And then I'll do it with the blue channel as well. I'll add our floor value to that. So we've added our floor value to each of the red, green, and blue masks coming out of our split node here. And now I'm going to take the result of that, and we're going to add that to our swizzle that we created down below. So I'm going to take this first swizzle, X and Y, and add it to that. And then we're going to do the same thing for our green and our blue. So I'm going to wire my ZX value into the green one. And I'm going to wire my YZ value into the blue one. And that is what I need to create my 3 individual sets of hexagonal grid tiles. So if we preview this, now you can see that I've got these individual tiles just like I showed you a minute ago when we were looking at the whole shader all together. Okay, so now I need to expose these 3 values to my output. So I'm going to come down here to my output value and select that. And then we're going to come over here to our graph inspector, and we need to set this up correctly. So I'm going to add 3 new values to our inspector. And this original value where I just had out vector 4, we're going to call this one our weights, because that is our red, green, and blue hexagonal grid. And then we're going to call each of these our grid ID 1, our grid ID 2, and our grid ID 3. And each of these need to be a vector 2 value because they're UV coordinate IDs. And so now we've got our vector 2s coming out, and then our weights we know is a vector 3 value. Okay, so we've got our output set up, and we just need to connect them to what we've just created. So I'm going to wire this into grid ID 1, this into grid ID 2, and this into grid ID 3. Okay, so once again, what we're doing here in part 5 is we're creating 3 unique sets of UV grids, and then we pass those out with grid ID 1, grid ID 2, and grid ID 3. All right, there's one other thing that we need to do to this subgraph in order for it to be ready. We need to add 2 more inputs in our blackboard. The first one that we need is UVs. So I'm going to add a new vector 2 value, and we'll call this UVs, and maybe drag it up to the top and drag this in. And instead of this hard-coded UV value, we're going to replace that with our incoming UVs. And so I'm just going to wire that right into the split value there in part 4. And now I can delete these values because we're going to be passing them in through this UV's input parameter. And then the other value that we need to use, or that we need to create, is a way to control the size of our grid. And that gets wired in right here with this divide node. So I'm going to come up here to our blackboard again and create another vector2 value, and we can call this one hex size. And this is going to allow me to control how large the hexagonal tiles are compared with the incoming UVs. So I'm going to wire... Oh, before I do this, we want to make sure that we don't divide by 0. So I'm going to take our hex size value. Oh, you know what? I messed up. This doesn't need to be a vector 2, so I'm going to delete it. And we'll make it again, and I'll just make it a float. We'll call this hex size again. And we'll give it a default value of 1. So now I can wire this in and connect it to my divide value there. Okay, we should be ready. We have our UV coordinates coming in. We have a parameter to control how big the hexagonal tiles are. And we have our parameter over here that controls the focus of the tiles, or how much blending there is in between the individual tiles. All right, and with that, we are all done with our subgraph. And we should be able to use this to assemble our final shader. So let's go and create a shader. And we'll drag this into it along with our UV random transform node, and we'll piece the whole thing together. Okay, so I'm going to come down here to my project and right click and pick create shader graph and create a new shader. And I'm going to call this test hex tiling. All right, let's open this up. And we've got a brand new shader to work on. So I just need to add a couple of subgraphs in here. We're going to add the Hex Grid demo subgraph that we were just working on, as well as our UV random transform subgraph that we made a couple of weeks ago. All right, cool. So we need 3 copies of this. So I'm just going to duplicate it 3 times. And now we're going to plug the output of our UV or of our grid ID from our Hex Grid demo node into the random seed of our UV transform. So the first one, and the second one, and the third one. So this is generating 3 different sets of hex grids. And so we're passing that into our random seed. So each individual tile of those 3 sets will get random transforms applied. All right, the next thing that I need is some UV coordinates. So I'm just going to type UV, and we're just going to multiply our UV coordinates by 12 for now, just to get some interesting looking tiling. And so we'll pass this set of UV coordinates both into our Hex Grid demo node as well as our UV random transform. So this is our initial set of UVs, and this is the set that's getting randomly transformed by these 3 nodes. Okay, so once the UVs are randomly transformed, we need to actually use them to sample something. So I'm going to add some texture samplers here. Need 3 of those. So I'll just copy and paste and wire in my random transformed UVs from my 3 UV random transform nodes. And now that our textures are sampled, the last thing that we need to do is blend them together. So the first thing that I'm going to do is multiply each of them by this weights value that's coming out of our Hex Grid demo node. So let's take a look at that really quick. I'm just going to turn on my preview here. And let's set the preview to be a quad. And I'm just going to wire my weights directly into base color so that you can see what's coming out of there. Yeah, so we've got our nice grid of red, green, and blue hexagonal tiles. And we're going to multiply each of our texture samples here by red, green, or blue. And so I need to bring this down and split it into its individual channels. And now I can multiply my texture by each channel. So I'm going to add a multiply node. And we're going to multiply the first one by red and the second one by green. And the third one by our blue channel. And now all that's left to do is add them together. Once they've been multiplied, so you can add them together like this, and then add the results of that one with the last one. And then just take our final results and wire it into our master stack. Now, it's going to turn out white because we haven't actually assigned any textures yet. And so we just need to go through here. Actually, you know what I'm going to do? I'm going to create a texture asset node. Texture 2D asset. And we're going to assign our texture here. We're just going to use our cobblestones texture. And then I'll wire this texture asset into the texture inputs of each of my samplers. And there we go. Now we have infinite tiling. I can tile this as many times as I want to, and it's never going to repeat. It'll always be unique for every single one of those hexagonal grid tiles. And there's no seams and no repeating. And it's just a really cool way of breaking up texture tiling. You can see that I could increase my UV coordinates to something super duper high, and I'm still getting the same result. I never repeat the pattern because every one of those hexagonal grid tiles is receiving its own set of random transforms, scaled, offset, and rotated. So I can use this for terrain, I can use this for texturing really large objects, all kinds of things where you would normally get tiling artifacts. I can use this technique to completely get rid of those texture tiling artifacts. Pretty cool. Now, there is one drawback to this, and that is because we're doing this random rotation, you can't randomly rotate a normal map. So if you want to apply this to a material and do the same thing with your diffuse texture, your mask texture, and your normal texture, don't randomly rotate normal maps because it doesn't work and you end up with lighting results that are incorrect. So if you want to do this with normals, you can either set your rotation min and max to 0, or you can edit your random or your UV random transform node to not do rotation so that you're not rotating your normal maps. Let's just take a look really quick and see what that looks like. If we turn off rotation, you can see that it's still breaking up the tiling, but it's not quite as good. You can kind of make out a repetitive pattern here. It works much better if we can randomly rotate that. Maybe this is a topic that I'll get into next week, talking about dealing with normals and random rotation. But for now, I think this is pretty good. Now, I wouldn't want to actually leave this with setting my rotation min and max to 0, because I think that it's still doing that math under the hood. It's just coming out with no rotation. And so if I wanted to use this with normal maps now, it would be better to go into my UV random transform and bypass the rotation portion of it rather than just pass in values of 0, because I think that it's actually doing that math and I'm having to pay for it even though I'm not using it. Okay, well, let's switch over to Unreal and I'll show you how to create this same hexagonal grid tiling there. All right, here we are in Unreal, and you can see that I've got my MF UV random transform node. This is the one that we've been working on for a couple of weeks. And then last week we created this Hex Grid node. And today we're going to be picking up and finishing this one off. Last week we created this weights. So if I drag this over and plug it into our base color node, you can see that we get our red, green, and blue hex grid. And so what we do with this is it generates 3 separate hexagon grids, and I pass those into our UV random transform as our random seed. So every hex tile gets a different random transform. And then I apply that random transform to the UVs and use it to sample our textures. And then I blend the textures together using the weights that are coming out of the Hex Grid node. One thing that I didn't mention when I was going over the Unity portion of this is the reason why we're using 3 different texture samples and blending them together. So if I just take a look at one of these texture samples and I zoom in, what you're going to notice is there are hard edges or hard seams. So here's the place where 3 hard seams come together right there. And what we're doing here is these 3 different grids that we're generating are offset from each other from center to center. So one of the grids has a nice tile that's right here in the place where these 3 edges come together. And another grid has a tile right here in this place where these 3 edges come together. And so what I'm doing is each grid has the center of its tile in the location that's completely offset from the center of the other grids. And so basically each grid is covering up the edges of the other grid. So I blend out of one grid when I'm getting to an edge and blend into the other one where there isn't an edge. And so with these 3 texture samples, I'm able to completely hide these edges here where the tile borders are. So that's the reason we're doing 3 different samples. Now, if you don't really care about these hard tile borders, you could get away with just doing 1 texture sample, and that would save you a lot on performance. But in order to get the best quality and get rid of these hard edges, we're doing 3 and blending them together with our weights value. And so we can completely hide those edges and get nice soft blending between the different hex grids. Okay, so what we're going to do today is finish working on this hex grid node. Last week we just created the weights, but I'm going to show you how to add grid ID 1, 2, and 3. And then we're going to come back and we'll assemble this material. So let's get going on our hex grid material function. So here's the material function that we were working on last week, and we called it MF Hex Grid Demo. And we built this in 4 different steps. And the only thing that I've changed between last week and this week is I've added in these groupings where I've isolated step 1, step 2, step 3, and then step 4 over here. So it's a little bit easier to tell what's going on. So what we're going to do today is build step 5, where we create grid ID 1, 2, and 3. So the first thing that we're going to do is come down here to step 2. And I want to take the result of this subtract node and drag it out, and we're going to add a new if node. So the if node is going to allow us to branch based on specific behavior. So I'm going to say if the result of this subtract node, and I'm going to add another node here that's 0. So if this value coming in is greater than 0, then we're going to return a 1. So we need to make this hard-coded value a 1. Otherwise, we're going to return a 0. So I'll just copy and paste that value and change it to 0. And then we'll plug that into the equals or less than. So if our subtract value is greater than 1, then we'll return a 1. Otherwise, we'll return a 0. All right, and we'll just pull this down here. Now we're going to take the value coming out of our round node, and we're going to multiply it by the result of our if statement. So we're going to multiply that. And then we're going to take the result here and split it into the RGB components. So I'm just going to create a split components node. And then I'm also going to take this round value here and create another split components. So we're splitting things out into their red, green, and blue channels. And now using this split components node, I'm gonna swizzle some things up a bit. So I'm gonna add an append node. And what we're doing here is creating independent sets of vector 2s or UV coordinates. So my first one is going to be red and green. My second one is going to be blue and red. My third one is going to be green and blue. So we're using our value here and just swizzling it up and getting 3 sets of UV coordinates from that. Now we're going to come back here to the beginning of step 1, and I'm going to wire a value out from this floor, and we're going to create an add node here. So we're going to add the floor value here to our blue channel. Then we're going to do it again. We're going to add the floor value to our green channel. And we're going to do it again. And we're going to add the floor value to our red channel. All right, now we're almost done. We just need to do one more add. So we're going to do another add here. And I'm going to add this append value. And we'll do it again. And add our second append value. And we'll do it a third time. And we'll add our last append value. And now we're ready to pass these values out. So we're going to create a function output. And we'll come over here to our output name and we'll call this grid ID 1. And copy it. And we'll call this grid ID 2. And then our last one will be grid ID 3. Perfect. So we got our output grids. And if I zoom in here, what you'll notice is that these UV grids, the hex grids, are offset. You can see this one is coming from the corner, and this one's offset from the corner, and this one's like offset down from the corner. So we have 3 different hex grids that overlap each other in different ways. And that's the technique that we use to hide the seams in the texture tiling. Okay, the last thing that I want to do is order these in sort priority. So we'll give grid ID 1 a sort priority of 0, grid ID 2 a sort priority of 1, grid ID 3 a sort priority of 2, and then our red, green, blue output a sort priority of 3. And that will make it so that the output ports are in the correct order from top to bottom. Okay, this material function is all set and it's ready for us to use in our final material. So I'll save that. And then I'll come down here to our content drawer and I'm just going to create a new material so that we can build it up. So I'll right click and pick material and we'll call this test hex tiling. And we'll open up this material. And now we need to drag in our material functions. So we need to bring in the MF Hex Grid demo material function that we just created. And we also need to bring in MF random transform material function. Now I'm going to duplicate this 3 times so we can have 3 different randoms. And I'm going to wire grid ID 1 into random seed of the first one, grid ID 2 into the random seed of the second one, and grid ID 3 into the random seed of the third one. Oh, you know what? I just realized I missed something here. Can you see how this is called result down here? We actually need to rename that weights. And so I'm going to open up my MF Hex Grid demo again and come over here to where it says results. And we'll type in weights there instead. And save this. And we'll switch back. And now you can see it's called weights instead. So I'm going to use the results of my random transform to sample my textures. So I'm going to add 3 texture sample nodes. And I'll use the output UVs. And I want to add a texture asset as well, so I just have to change the texture one time. So I'm going to add a texture object, and then we'll set this texture to our cobblestones texture. There's our cobblestones texture, and I'll plug it into my first texture sample, and my second texture sample, and my third texture sample. Alright, I'm going to set my preview here to a cube, and I'm going to set my field of view to 50 so that it looks a little bit nicer to preview. And just so we can see things a little bit better, I'm going to set it to unlit because we're not really dealing with lighting right now. Alright, if we wire our first texture into the base color on our root node here, you can see that we have all of these tiling grid squares. I think there is one other change that I need to make to my MF Hex Grid demo. Actually, there are a couple of more changes that we need to make here. We need to add some inputs, so let's go ahead and do that. So here in step 3, I'm going to add a function input. And this, instead of being a vector 3, I'm going to change it to be just a scalar. And this is the value that controls the focus. So I'm going to call this grid focus. And we're going to give it a default value of 12. And I'm going to come down here and check this use preview value as default. This is going to control the sharpness of the edges of the blending between the grids. So I'll delete this hard-coded value of 12 here, and we'll pass in this input value here. The other input value that I need to add is right here. This controls the size of the grid squares themselves. I'm going to come over here and just copy this one, and come over here and paste it. And we're going to call this grid size. And I'll give it a default value of 1. And then we're going to wire that into the divide. I can delete this one here. And then the last value that we need is our input texture coordinates. So I'm just going to clone this input here, bring it up here, and we're going to change this. Instead of a scalar, it's going to be a vector 2. And we'll call this our UVs. And I'm going to wire the texture coordinates here in to use as the defaults. And then I'll wire this into my mask red and my mask green. So now we're no longer multiplying our size by 12. And so it might look kind of weird over here, but it is going to work correctly when we set up our material and use this as a function inside that material. Okay, I think I'm all set on this, so I'm going to save it again. And now you can see our MF Hex Grid demo has Hex Grid size as an input, UVs, and grid focus. But they're not in the right order, so I'm going to come back here and reorder these. I want my UV coordinates to be first, so I'm going to set the sort priority on that one to be 0. I want the grid size to be second, so I'll set the sort priority to 1. And I want the grid focus to be third, so I'll set sort priority to 2. We'll save that and switch back to our material again. Now you can see I've got UVs, grid size, and grid focus. So here I'm going to set my grid focus to be 12. And I'm going to set my grid size to be 1. And then I'll bring in my UVs. And we'll multiply our UV coordinates by 12, just to tile it a whole bunch. There we go. So I'm going to pass the UVs into my Hex Grid material function here, and then also into my random UV transform nodes here. Great. So now I've got 3 separate UV random transforms, and I've got 3 separate texture samples. And the last thing that I need to do is blend my samples together. So I'm going to take my weights out here, and we'll use a split components node to split the weights into red, green, and blue. Then we're going to multiply our first texture by red. We'll multiply our second texture by green. And we'll multiply our third texture by blue. And then all we have to do is add the results together. So I'll add this one with this one, and then I'll add the result of that to my third one. And now I've got my textures all blended together, and I can wire the output into my base color. And there we go. Now we have our infinitely tiling grid. This is such a cool technique because it allows you to tile this as many times as you want. It can tile forever, and you never see any repeating at all. So if I want to, you know, I can multiply this by, I don't know, 128, let's say, and just tile it to infinity, and it just never repeats. Of course, you can't see individual tiles if you do that. Let's cut this down to 32 maybe. And you can see that there's no pattern here. It just goes forever with zero tiling at all. Such a neat technique. There are some things we can adjust if we want to. We could play with our grid size. One thing that might be interesting would be to increase the size of our hexagon grids. So if we make our hexagons significantly larger, you can see that each hexagon now has 3 tiles of our texture in it. So you actually do see some texture tiling. So we want to keep this kind of low so that the textures don't tile. Maybe, I wonder if we do 1.73, what that would do. So you can see a little bit of tiling here, but there's really not much repetition. I don't know, maybe a value of 1 just works best here. This is basically determining the relationship between the hex tiles and the UV coordinate tiles. So a value of 1 means that there's 1 tile of UVs per 1 tile of hexagons, but you can make this larger or smaller, just depending on what you need. And also depending on the content of your texture. We have this texture with the nice cobblestones in it, but if you have a different texture with a smaller or larger pattern, you might want to make your hex tiles larger or smaller. And then the other thing that you can do is change how much scaling is happening. We have a default value of 0.8, so our texture can scale down to 0.8 of its normal size or scale up to 1.2 of its normal size. But if we want to make adjustments here, we could scale this down as far as we wanted to. We could go down to 0.1 as our minimum scale, and maybe 5 as our maximum scale, so there'd be tons of variety. Now this is going to look pretty crazy. You can see some of the tiles are teeny, and some of the tiles are huge. And that looks pretty nutty, but you can get all kinds of variety from this. In our case, we probably don't want such a huge spread between really large tiles and really small tiles, because it gives away where the edges or where the borders of the hex grid is. And so keeping these kind of close together, maybe 0.7 and 1.5 might give some more realistic results. But yeah, you can do all kinds of really interesting things just by playing around with these values. Okay, well that about does it for today. I've shown you how to use our hex grids in combination with our UV random transforms to allow us to tile textures infinitely. Now, like I said, when we were talking about the Unity version of this, this doesn't work for normal maps because you can't rotate a normal map. So maybe next week we'll get into what needs to happen in order to use this same technique on a whole material, where you want to apply those same random transforms to your diffuse texture, your normal texture, and your mask texture, and you want to correctly handle the normals. Let me know down in the comments if you have any questions. And until next week, I hope you guys have a great week and come back next week to see more shader goodness.